Hello, trig fans. Hope you're having a good Monday morning. Sort of wet and dreary out there. I hope all is going well with your family and hope all is going well with you, keeping our social distancing. Once again, if you have any questions at any point here, email me the questions. We'll go over any type of questions. We're going to continue on with what we did the other day or last week with respect to principal values. I've posted these notes online. I posted a worksheet, an extra practice worksheet also online with the solutions. And once again, try to work yourself through them. Try to work yourself through the problems, and we'll go through some problems here today that are very similar to what you'll see on the worksheet. So hopefully you can follow along between the two. Once again, if I go too fast, just hit your pause button. Hit your pause button. I promise I will not continue to talk. Okay, and then when you're ready to go again, just go ahead and hit play again. Okay, today what we're going to do is this is a review. Once everything that we've talked about with respect to principal values. We talked about a principal value, that's your calculator value. Okay, we symbolize with the principal value with a capital letter. So if I have a capital S or a capital C there, that means we're talking about a principal value. When we are dealing with theta, we have to make sure our calculator is in a degree mode. And when we are in X, we need to make sure our calculator is in a radian mode. So once again, you just hit your second function. You hit your mode button. Hit your mode button, and you'd be able to switch between radians and degrees and degrees and radians. And once again, I will show you. You have to continue to check. My suggestion to you, as you're working through the worksheet, do all the theta problems first. They're all in the left-hand column, and then go to your radian column so you're not flipping back and forth, and sometimes you'll forget to flip back and forth, and that's an issue then. So just go ahead and do all your theta problems, then switch to the radian mode, and then do all the radian problems. And once again, how you switch the mode, if you look, I hit my mode button. I'm in a radian mode right now. If I want to change to a degree mode, I just highlight my blinker on degree and hit enter, and I'm in degree mode. If it's on degrees and I want to go to radians, I just change it to radians that way. So you just need to make sure that you continue to check to make sure you're in the correct mode. When you're dealing with two general solutions, once again, we talked about the other day where you have an infinite number of solutions. If you have an infinite number of solutions, how do I come up with those infinite number of solutions? Well, the infinite number of solutions for the inverse sign is the principal value. Once again, that's your calculator value, plus or minus the period n, and the supplement, okay, plus or minus the period n. Now, for our purposes right now, the period is going to be over here in the degree mode, 360 degrees. Eventually, we'll evolve into a period that's a little bit different than that. When we deal with more of the radians. Over here, when we're in a radian mode, the period is going to be 2 pi. That's in the radians, and this is when we're in degrees. So when we have the period n, that's a radian, or you have to look to see, do I have degrees in theta, or do I have radians in x? Okay, so inverse sign, we have principal value plus or minus the period n, and then it's supplement. Now, when we're dealing with the supplement, okay, when in theta, we are in a degree mode. How we calculate the supplement is 180 minus our principal value. But if I'm in the x mode, I take pi, which is, we can approximate 3.14, and subtract off the principal value. For the inverse cosine, it's a little bit easier. We just have principal value plus or minus the period n, and then the opposite, which means if this is positive 20 degrees, this would be negative 20 degrees, plus or minus the period n. Once again, when in theta, we are degree mode. When in x, we are in radian mode. Okay, what we're going to do is we're going to go through some examples. Okay, inverse cosine of negative 0.71. Directions say I want two general solutions and the first three positive smallest values. So that's what we're looking for here. So I'm dealing with the inverse cosine. If we look at inverse cosine, we have principal value, and once again, How do we find the principal value? That's exactly correct. We use our calculator. So we can clickety clack through our calculator, go ahead, inverse cosine. Now, one thing we need to note here, our variables in theta. So referring back to when we're variables in theta, we need to make sure we are in a degree mode. So let's make sure we are in a degree mode, so check your mode first. So we have mode. Oh, I was in the radian mode, so if I would have done the problem, I would have been incorrect. I need to change to theta and degrees. Quit out of that. And let's do the inverse cosine of negative 0.71. Don't lose your negative sign. And the measure you should come up with is 135.23 degrees. Okay? And this would be plus or minus the period n, which is, in our case, for right now, 360 degrees n. Okay? So we're dealing with the inverse cosine. We have the principal value, which we just calculated with our calculator, because that's what our calculator will give us. And then our second general solution comes from the opposite to the principal value. Okay, so if I have 135.23, the opposite of that would be, you're exactly correct, negative 135.23 degrees, plus or minus 360 n. Now, if you remember, what we could do with that n is we could get an infinite number of solutions. We could put an n value of 1 in there, 2 value 3, 4, 5, 6, 7, 8, 13, 27, whatever. And if I would calculate this out and I would take the cosine of that angle, I should come down to something very close to negative 0.71. Then the next thing we have to do is get our first 3, which is our first smallest positive values. Okay, so we take a look at our positive value. Now, I can take 135, either add or subtract 360 degrees. Well, if I subtract it, that's going to get me negative. I'm not going to want that. If I add it, I'm going to get bigger than that. So, I look at the other one down here. I get negative 135. That's a negative. So, to take that into the positive world, we can add 360. 5.23 plus 360. And let's see what that comes up with. Let's just make sure that this is not going to be smaller than the 135. $360 minus 135.23. We get 224.77 degrees, which is not smaller than this. So I'm going to take this value here as my smallest. This would be my second. And then to go from 1 to 3, if you remember back to what we did last week, we played leapfrog, we add the period, which is 360 degrees. So we have 135 plus 135.23 plus 360. And you get 495.23 degrees. And if I would take the cosine of this angle, I should come down to close to negative 0.71. All right, now let's go to the second one. Let's take a note where our variable is at. Our variable is in x. So if our variable is in x, we got to switch it to radians. Don't forget to do that. So change your calculator to radian mode. And let's take the inverse cosine of 0.45. And we get 1.01. Oh, I think I botched that up. 1.10, my bad. Plus or minus the period end. Now, since we're in a radian mode, we had to make sure we get our 2 pi in there rather than 360 degrees, because our equivalent to 2 pi is 360 degrees. And then our second value, once again, second value, we have to do the opposite. So we have negative 1.10 plus or minus 2 pi n. Take it out to 2 decimal places because we'll use 3.14 and 6.28 with your pi as approximations. And now it's the same process we did over here, just the numbers will be a little bit smaller. 2 pi, once again, this value here is 6.28. So if I take 1.10, subtract that off, I'm going to get negative. This is going to make me much bigger than 1.10, so my first value is 1.10. My second value, I can come to this one here, negative 1.10 plus 6.28. And we get 5.18. And then to go from 1 to 3, once again, we play leapfrog. We add the period, which is in this case 6.28. So we should come down to 7.38. Inverse cosines tend to be a little bit easier because you don't have to worry about the supplement. Let's look at some inverse sine problems. Once again, we are in theta, so make sure our degree measure goes back to our degree mode is in degrees, our calculator mode is in degrees. Once again, what I suggest you do, so you don't have to continue to flip-flop through the homework, all the left-hand side problems are in theta, and then the right-hand column problems are in x. Go ahead and do all the theta problems first, so you're in the degree mode. Switch to your radian mode and do the right-hand side, which is your radian mode. But we'll go back to our degree mode. Okay, we had to take the inverse sine of negative 0.82. Now, once again, the calculator value will give you that first value, which is the principal value. So we have inverse sine, second sine of negative 0.82, and you get negative 55.08 degrees. Plus or minus the period n, which once again is still 360 degrees. Now comes the tricky part. How do we find the supplement to this? Well, how do we find the supplement? We've talked about this numerous times. The supplement is 180 minus that principal value. So we have to really watch. We have 180 degrees minus a negative 55.08. So we have minus negative, so we got to do a little boom ching in there. So we boom ching this, boom ching. So we have 180 plus 150 or 55.08. So we're going to have 180 plus 55.08. So we come down to 235 plus or minus 360 n. I should probably put in the 0.08. My bad. 235.08 plus or minus 360 n. Now, once again, what's our definition? What's our definition of supplementary angles? Two angles that add together that equal 180 degrees. That's the definition of supplementary. Two angles that add together to equal 180. So if I take negative 55.08 plus 235.08, add them together, we get 180 degrees. So they are supplementary. They don't have to be between 0 and 180. It could be bigger. First three positives. Okay, we have 235, that's positive. This one's negative. So to make it positive, we can add the 360. So we have 360 plus a negative 55.08. Don't lose track of your negative. And you get 304.92. So our first smallest positive value would be this, 235.08. This would be our second, 304.92. And then playing leapfrog, once again, we add the period, which in this case is 360 degrees. So we have 235.08. Plus the 360, so we have 595.08. And once again, if you would take the sine of that value, not the inverse sine, the sine of this angle, go ahead and try it, sine of 59.08, or 595.08, you get negative 0.81995, close to negative 0.82. Okay, last one. Last one, we have the inverse sine, but once again, let's make sure we know we are in X, so we need to make sure we are in what mode? That's exactly correct. Need to make sure we're in the radian mode. So go to your calculator. Change your radian mode. Let's take the inverse sine of 0.79. Get your principal value. Then go ahead, find its supplement. Now remember, supplement in this case, we have our supplement is pi minus the principal value. So we have 3.14 minus our principal value. So we get 0.91 plus or minus 2 pi, and make sure 2 pi because we are in X. If we're in X, we need to get 2 pi in there. And take it 2 decimal places once again because we're going to use the 3.14. So our supplement is 3.14 minus 0.91. Which is 2.23. Plus or minus 2 pi n. First three positives. Well, the first two are already given to us. Once again, 2 pi is 6.28. So you're either going to add or subtract 6.28. Well, if I add or subtract 6.28, if I subtract it, these are both going to be negative. So we don't want that. So we're going to add, or take our first two values, 0.91, 2.23, and then to go from 1 to 3, we leapfrog. So we can add 6.28, which is your 2 pi, which is the period of it. So we have 6.28 plus 0.91. So we get 7.19 as our first three values. Once again, I gave you some a worksheet with some similar problems to it. The first four are principal values, so you just get one value to that. They're capital letters. The bottom values are these types of problems here, so that gives you some additional practice in regards to the principal values. Once again, If you have any questions, please feel free to email me or message me through Google Classroom. I'm really sorry about, I'm trying to get just information back in regards to how it's going for you with respect to the online stuff. And for some reason, I'm a tech dummy and Google Classroom is not working for me getting information back. I'm sorry for having you redo that survey. Hopefully it can give me some information, because I need to know from you if there's issues or if there's problems that you're running into. Hopefully you've had a good weekend. Hopefully you got some Double D ice cream going for you, okay? Hope everything is safe at your house. Hope everybody's safe. Please make sure that you continue with your social distancing. Stay away from people, because we would like to get things back to normal as quickly as possible. And the more people congregate, the more that we don't have that social distancing and we can pass this from one to another. So just please try to keep your social distancing and be smart and use common sense. Once again, if you have any questions, feel free to contact me. I miss you guys. I wish we were back to normalcy, but we aren't. So I appreciate you trying to get through some of this work for us and being diligent with it. I'm trying not to tax you too much in regards to it. I'm trying to make it so it's easy for you to continue to understand and comprehend. Once again, if you have questions, email me. If you don't, adios. Have a good day.